Welcome to this comprehensive module on logging, monitoring, and alerting, with a special focus on logging software. In today's complex IT environments, effective logging and monitoring are not just nice-to-have features, they're absolute necessities. In this module, we'll explore various logging solutions, with a particular emphasis on the ELK stack, Elasticsearch, Logstash, and Kibana. We'll examine how these tools work together to create a powerful logging and monitoring system that can handle enterprise-scale requirements. Whether you're managing a small development environment or a large-scale production system, the principles and practices we'll discuss will help you implement effective logging strategies that support both troubleshooting and proactive system maintenance. Let's begin this journey into the world of logging and monitoring, where we'll transform raw log data into actionable insights that drive system reliability and performance. Let's dive into the world of logging software. It is critical to choose the right logging solution for your specific needs. We'll start with some of the fundamental logging solutions that have stood the test of time. Syslog, for instance, has been a cornerstone of system logging since the early days of Unix and continues to be relevant today. Its simple yet effective protocol has influenced many modern logging solutions. RSyslog builds upon the traditional syslog protocol, adding features like reliable TCP transport, advanced filtering capabilities, and support for various output formats. Some teams effectively use rsyslog to handle thousands of messages per second in production environments. The systemd journal represents a more modern approach to logging, particularly on Linux systems. It offers features like structured logging and automatic log rotation that make it especially valuable in containerized environments. Fluent has gained significant popularity in cloud-native environments. Its ability to unify data collection and consumption makes it particularly valuable in microservices architectures where logs come from multiple diverse sources. Finally, we'll focus extensively on the ELK stack, which has become a de facto standard for centralized logging in many organizations. The combination of Elasticsearch's powerful search capabilities, Logstash's flexible data processing, and Kibana's visualization features creates a comprehensive solution that can scale from small teams to enterprise deployments. Each of these tools has its place in the logging ecosystem, and understanding their strengths and use cases will help you make informed decisions for your own logging infrastructure. The ELK stack represents one of the most powerful and flexible logging solutions available today. Let me share why this combination of tools has become so popular in the DevOps community. Starting with Elasticsearch, we have a distributed RESTful search and analytics engine that excels at handling large volumes of data. Its ability to scale horizontally by adding nodes to the cluster makes it particularly suitable for growing environments. Logstash serves as the data processing pipeline, ingesting data from multiple sources simultaneously. One of its strongest features is its extensive collection of input plugins. Some teams use it to collect everything from traditional application logs to social media feeds and IoT sensor data. Kibana completes the stack by providing visualization capabilities that transform raw data into meaningful insights. Its intuitive interface allows even non-technical users to create powerful dashboards and explore data patterns. However, it's important to understand both the advantages and challenges of implementing the ELK stack. While it offers exceptional analytics capabilities and scalability, it does require significant expertise to set up and maintain properly. Some teams struggle when they underestimate the complexity of managing a production ELK deployment. Resource requirements are another crucial consideration. Elasticsearch, in particular, can be memory-intensive, and proper capacity planning is essential. I recommend starting with a small deployment and scaling up based on actual usage patterns rather than trying to build a large cluster from the start. Despite these challenges, the benefits of the ELK stack often outweigh the complexities, especially in environments that require sophisticated log analysis and visualization capabilities. The key is to approach implementation methodically and ensure you have the necessary expertise available. Logstash is the workhorse of the ELK Stack's data ingestion process, and understanding its capabilities is crucial for effective log management. Let me share some practical insights about working with Logstash. The true power of Logstash lies in its versatility. Through its plugin ecosystem, it can ingest data from virtually any source. Perhaps the most commonly used input plugins are the File Input plugin for traditional log files, the Beats Input plugin for lightweight data shippers, and the Syslog Input plugin for network logging. One of the most valuable features of Logstash is its data transformation capabilities. The filter plugins allow you to parse, enrich, and transform your logs before they reach Elasticsearch. Scaling Logstash effectively requires careful consideration of your pipeline configuration. I recommend implementing multiple pipelines when dealing with different types of logs, as this allows for better resource utilization and more focused processing rules. A word of caution: while Logstash is powerful, it can be resource intensive. In high-volume environments, you might want to consider using Beats as a lightweight alternative for data shipping, with Logstash handling only the logs that require complex processing. Elasticsearch serves as the heart of the ELK stack, providing the storage and search capabilities that make complex log analysis possible. One of Elasticsearch's key strengths is its ability to handle full-text search efficiently. This is particularly valuable when dealing with log messages that contain unstructured text. Some teams dramatically reduce their incident response times by using Elasticsearch's powerful query capabilities to quickly locate relevant log entries. The indexing strategy you choose can significantly impact performance. While Elasticsearch is schema-less by default, defining an explicit mapping for your indices can improve both search performance and storage efficiency. I typically recommend starting with daily indices for time series log data, as this makes it easier to manage retention and optimize storage use. One crucial aspect often overlooked is the importance of proper index lifecycle management. In production environments, you'll want to implement policies to handle the aging of your log data, perhaps moving older indices to less expensive storage tiers or removing them entirely after a certain period. When working with Elasticsearch, it's essential to understand its distributed nature. The way you configure sharding and replication can significantly impact both performance and reliability. I generally recommend starting with a single shard per index when your daily log volume is under 30 gigabytes, and scaling from there based on your specific needs. Kibana transforms raw log data into visual insights, making it an invaluable tool for both operations teams and business stakeholders. The dashboard creation capabilities in Kibana are particularly powerful. The ability to combine different types of visualizations, from simple line graphs to complex heat maps, allows you to create comprehensive views of your system's behavior. Real-time monitoring is another area where Kibana excels. The ability to refresh dashboards automatically means you can maintain constant visibility into your system's health. Some operations teams use this capability to detect and respond to issues before they impact users. One of the most valuable features is the ability to customize dashboards for different audiences. For example, you might create detailed technical dashboards for your DevOps team while maintaining simpler, high-level dashboards for management stakeholders. Remember that effective visualization isn't just about creating pretty charts, it's about making data meaningful and actionable. When designing Kibana dashboards, always start with the questions you're trying to answer, rather than the visualizations you want to create. Understanding the end-to-end workflow of log analysis in the ELK stack is crucial for effective implementation. Let me walk you through this process based on real-world implementations I've been involved with. The workflow begins with log ingestion through Logstash. In production environments, this often involves multiple input sources, application logs, system metrics, network logs, and more. One critical aspect of the ingestion process is ensuring data quality. Your Logstash filters should clean and normalize the data before it reaches Elasticsearch. For example, you might want to standardize timestamp formats, extract common fields, or enrich the data with additional context. The storage phase in Elasticsearch involves more than just writing data to disk. Proper index management is crucial. This includes setting up index templates, managing life cycles, and implementing appropriate retention policies. Some organizations significantly reduce their storage costs by implementing smart indexing strategies. The final step, visualization in Kibana, is where your log data becomes truly valuable. This isn't just about creating dashboards, it's about enabling users to explore and understand their data. I recommend starting with a few key dashboards that answer your most common questions, then iteratively adding more as needs arise. The benefits of implementing ELK logging extend far beyond simple log aggregation. Let me share some concrete examples of how organizations have derived value from their ELK implementations. Centralization is perhaps the most immediate benefit. Instead of logging into multiple servers or applications, teams can quickly search across their entire infrastructure from a single interface. The search capabilities provided by Elasticsearch transform the way teams interact with their log data. Rather than grepping through log files, engineers can use powerful queries to find exactly what they're looking for. Some teams solve in minutes what used to take hours of log parsing. The analysis capabilities enable proactive system management. Real-time monitoring through Kibana dashboards has become a crucial tool for many operations teams. The ability to visualize system behavior in real time allows for quick detection of anomalies and potential issues. Some organizations significantly reduce their mean time to detection, MTTD, by implementing well-designed monitoring dashboards. However, it's important to note that these benefits don't come automatically. They require thoughtful implementation and ongoing maintenance. The key is to start with clear goals and gradually build out your logging infrastructure as your needs and expertise grow. In security monitoring, ELK has proven invaluable. For application performance monitoring, teams may use ELK to track response times, error rates, and user behavior patterns. One particularly effective implementation involved creating Kibana dashboards that showed performance metrics alongside application logs, making it easier to correlate slow response times with specific events or code changes. In the compliance and auditing space, ELK provides the detailed logging and reporting capabilities needed to meet various regulatory requirements. For business intelligence, the ELK stack can provide valuable insights into user behavior and system usage patterns. One e-commerce company I consulted with used their ELK implementation to track user journey patterns and identify potential improvements in their website navigation. These use cases demonstrate how ELK can be adapted to various needs while providing consistent value through its core capabilities of log aggregation, search, and visualization. Data enrichment is crucial for getting the most value from your logs. Some teams significantly improve their troubleshooting capabilities by adding contextual information to their logs during processing. For example, adding environment tags, service names, or geographic information can make logs much more useful for analysis. Regular maintenance is often overlooked but absolutely critical. Implement automated monitoring of your ELK stack itself, and establish clear procedures for index management and cluster maintenance. Backup and recovery strategies should be established early. While Elasticsearch provides replication for high availability, this isn't a substitute for proper backups. I recommend implementing snapshot-based backups and regularly testing your restore procedures. Security cannot be an afterthought. Beyond basic authentication and encryption, consider implementing role-based access control to ensure users only have access to the logs they need. Remember that these best practices should be adapted to your specific needs and environment. Start with the basics and gradually implement more sophisticated practices as your usage of the ELK stack matures. Let's explore the monitoring capabilities of the ELK stack. Proper monitoring can transform system operations from reactive to proactive. When it comes to collecting metrics, the ELKA stack offers remarkable flexibility. You can gather data from virtually any source in your infrastructure. Log-based monitoring is where ELK really shines. The ability to centralize logs and analyze them in real time provides invaluable insights. The real power comes from combining different types of metrics and logs. For example, you might correlate application error logs with system metrics to understand if performance issues are related to resource constraints or application bugs. This holistic view of your system's health is crucial for effective troubleshooting and capacity planning. The visualization and alerting capabilities of the ELK stack form the backbone of effective system monitoring. Predefined dashboards are incredibly valuable for different teams and use cases. For instance, you might have one dashboard focused on system health metrics for your operations team, another showing application performance metrics for developers, and a high-level overview dashboard for management. Some organizations significantly improve their incident response times by having these targeted dashboards readily available. One often overlooked aspect is the importance of historical trend analysis. By maintaining historical metrics, teams can identify slow-developing issues and make data-driven decisions about system scaling and optimization. System metrics form the foundation of effective monitoring, and the ELKA stack provides powerful capabilities for collecting and analyzing these vital signs of your infrastructure. When monitoring system metrics, it's crucial to collect data at the right granularity. Some teams struggle with both extremes, collecting too much data, which strains storage and processing resources, or too little data, which leaves blind spots in their monitoring. Based on experience, I recommend starting with basic CPU, memory, and disk usage metrics at 1-minute intervals for most systems. Application metrics require careful consideration of what to measure. Beyond basic response times and error rates, consider measuring business-specific metrics that indicate the health of your application. Network metrics are often overlooked, but can be crucial for diagnosing issues. Monitoring network throughput and latency can help identify potential bottlenecks before they impact users. Log-based monitoring is a powerful approach that can provide deep insights into system behavior. When it comes to detecting errors and anomalies, log analysis can reveal patterns that might not be visible through metric monitoring alone. Pattern identification is particularly valuable for security monitoring. One organization I advised used log analysis to detect potential security threats by identifying unusual access patterns across their systems. The ability to correlate logs from different security tools helped them improve their threat detection capabilities significantly. For investigating security incidents, having centralized, searchable logs is invaluable. Some teams reduce their incident investigation time from hours to minutes by having proper log-based monitoring in place. The key is to ensure you're collecting the right logs and structuring them in a way that makes investigation efficient. Remember that effective log-based monitoring requires proper log management practices, including log rotation, retention policies, and data lifecycle management. Without these, you risk either losing valuable historical data or overwhelming your storage resources. Visualization in the ELK stack, primarily through Kibana, transforms raw data into actionable insights. Line charts are particularly effective for showing trends over time. The key is to choose the right time window and aggregation level. Too much detail can obscure important trends, while too little can miss critical patterns. Bar charts excel at comparing values across different categories. For instance, one organization I advised used bar charts to compare error rates across different services, making it easy to identify which components needed attention. Consider using stacked bar charts when you need to show composition within categories. Pie charts, while often overused, can be effective for showing proportions. However, I recommend using them sparingly and only when comparing a small number of categories. Some teams effectively use pie charts for things like storage usage by service or traffic distribution across regions. Maps can provide valuable insights for geographically distributed systems. Real-time alerting is critical for maintaining system health and responding to issues quickly. Threshold alerts are the most common type, but setting appropriate thresholds requires careful consideration. Some teams struggle with alert fatigue from thresholds that were too sensitive, and miss important issues with thresholds that were too lenient. One effective approach I've used is to start with conservative thresholds and adjust based on actual experience. Query-based alerts can be more sophisticated than simple thresholds. Predefined dashboards in the Elkey stack serve as powerful tools for different teams and use cases. System performance dashboards should provide a clear overview while allowing quick drill down into details. Application health monitoring requires different perspectives for different stakeholders. Developers might need detailed performance metrics and error logs, while business stakeholders might be more interested in user experience metrics and business KPIs. Some teams successfully use role-based dashboard assignments to ensure each group gets the information they need. Network monitoring dashboards often benefit from combining multiple visualization types. For instance, one team I advised created dashboards that showed network topology maps alongside performance metrics and error rates, making it easier to correlate issues with specific network segments. The alerting capabilities in the Elk stack, particularly through the Watcher feature, provide powerful tools for proactive system monitoring. Watcher is Elasticsearch's native alerting engine, and its flexibility allows for sophisticated alert conditions. Creating effective watches requires careful thought about both the trigger conditions and the actions to take. I recommend starting with simple conditions and gradually adding complexity as you understand your system's patterns better. One organization I advised initially struggled with alert fatigue until they refined their watch conditions to focus on truly actionable events. Threshold alerts are common, but the real power comes from combining multiple conditions. For example, you might want to alert only if CPU usage is high and response times are degraded, reducing false positives from normal high-load situations. Query-based alerts can be particularly powerful for detecting unusual patterns. Let's dive deeper into the practical aspects of implementing alerting with Watcher in the Elk stack. Defining watches effectively requires understanding both your system's normal behavior and what constitutes an actionable alert. When it comes to conditions and queries, it's crucial to build in appropriate thresholds and time windows. For instance, rather than alerting on any error, consider alerting when the error rate exceeds a certain percentage over a specific time period. Some teams effectively use sliding windows to detect unusual patterns while avoiding false positives from brief spikes. The trigger configuration is equally important as the conditions themselves. Consider factors like frequency of evaluation and throttling to prevent alert storms. One organization I advised implemented a graduated alert system where different severity levels had different notification frequencies and recipients. Creating effective watches in the Elkey stack requires careful consideration of both technical and operational factors. Watch components need to be designed with both accuracy and performance in mind. When defining conditions, it's important to consider not just the immediate trigger but also the context. For example, one organization I advised created watches that considered both the absolute value of metrics and their rate of change. This helped them catch rapidly developing issues that might not trigger threshold-based alerts. Triggers need to be carefully timed to balance responsiveness with resource usage. I recommend starting with conservative evaluation intervals and adjusting based on your specific needs. Remember that more frequent evaluations consume more resources and might not always provide additional value. Watch management becomes increasingly important as your alerting system grows. Implement version control for your watch definitions and maintain documentation about why each watch exists and who owns it. This becomes crucial when troubleshooting alert storms or updating alert conditions. The actions and integrations available in the ELK Stacks alerting system provide powerful ways to respond to detected conditions. Email notifications are common, but their implementation requires careful thought. Webhook integration can be particularly powerful for automation. One organization I advised used webhooks to automatically create incident tickets and trigger runbooks when certain conditions were detected. This helped them standardize their incident response process and reduce manual intervention. Custom scripts can provide sophisticated responses to alerts. For instance, some teams implement scripts that automatically collected additional diagnostic information when an alert was triggered, making it easier for engineers to investigate issues. The key to effective actions is ensuring they're appropriate for the alert's severity and context. Consider implementing different actions for different severity levels, perhaps sending minor issues to a monitoring channel while paging on-call engineers for critical problems. This assignment will give you hands-on experience with setting up and configuring the ELK stack using Docker Compose. Let me explain why this is valuable and what you'll learn from it. Working with Docker Compose for ELK deployment is a common requirement in modern DevOps environments. Through this assignment, you'll gain practical experience with container orchestration, service configuration, and log management skills that are highly valued in the industry. Many organizations use similar containerized ELK deployments in production. The skills you'll develop here directly translate to real-world scenarios. For instance, one startup I advised used almost exactly this setup as their initial logging infrastructure, later scaling it as their needs grew. The assignment involves creating a Docker Compose.yml file that defines 3 services: Elasticsearch, Logstash, and Kibana. You'll learn how these components work together and how to configure them properly. This includes understanding container networking, volume management for data persistence, environment variable configuration, service dependencies. Pay special attention to the configuration details. These are similar to what you'll encounter in production environments. The skills you learn here will be valuable whether you're working with ELK Stack or other containerized applications. Let's examine the Docker Compose configuration in detail. This configuration represents a production-ready setup that can be successfully deployed in several organizations. The Elasticsearch service configuration includes crucial settings for production use. The single node discovery type is suitable for development, but in production, you'd want to configure appropriate discovery settings for cluster formation. For the Logstash service, note how we're mounting configuration volumes. This approach allows you to modify configurations without rebuilding containers, a practice that can save significant time in production environments. The pipeline configuration can be updated and Logstash restarted without affecting the entire stack. The Kibana service configuration demonstrates proper integration with Elasticsearch. The environment variable setting for Elasticsearch hosts is crucial. Some teams struggle with connectivity issues until they properly configured this setting. The volume configuration at the bottom is particularly important. Using named volumes for Elasticsearch data ensures persistence across container restarts, a lesson many teams learn the hard way when they lose data using unnamed volumes. Let's break down the key components of our Docker Compose configuration and understand why each choice matters. This knowledge comes from real-world deployment experience and lessons learned in production environments. The version specification in the Docker Compose.yml file is crucial. I recommend using version 3 as it provides a good balance of features and compatibility. Some teams run into issues with older versions lacking features they needed for proper service orchestration. Each service definition includes carefully chosen settings. For Elasticsearch, the single node discovery type is perfect for development and testing. The Logstash configuration demonstrates proper separation of concerns. By mounting configuration directories as volumes, we enable easy updates without rebuilding containers. The depends underscore on directive ensures proper startup order. While it doesn't guarantee application-level readiness, it prevents many common startup issues. The ingestion configuration for Logstash is a critical component that often determines the success of your logging infrastructure. The input configuration shown here demonstrates a common pattern for collecting system and application logs. The File Input plugin is one of the most widely used, but it's important to understand its nuances. Let's dive deeper into the Logstash pipeline configuration. I've implemented similar configurations across numerous production environments, and there are several key considerations to keep in mind. The filter configuration shown here uses the Grok pattern matching to parse syslog messages. This is a common use case, but the power of Grok extends far beyond this simple example. The output configuration demonstrates sending processed logs to Elasticsearch. The index naming pattern using datestamps is particularly important. One crucial aspect not immediately visible in the configuration is the importance of testing your Grok patterns. I always recommend using the Grok debugger in Kibana during development. The timestamp handling in your pipeline configuration is also critical. Improper timestamp parsing may lead to logs appearing out of order or with incorrect dates in Elasticsearch. Always ensure your timestamp parsing matches your log format exactly. Let me walk you through the practical aspects of using this ElkaStack configuration based on real-world deployment experiences. Directory structure is crucial for maintainability. Some teams struggle with configuration management until they implemented a clear directory structure like the one shown here. Keeping your Logstash configurations separated into config and pipeline directories makes it much easier to manage and update configurations independently. When placing Logstash configuration files, remember that these files need to be accessible to the Logstash container. Running the stack with Docker Compose up is straightforward, but there are some important considerations. First, ensure you have adequate system resources available. Monitor the startup sequence carefully. While Docker Compose handles basic service dependencies, I recommend watching the logs during the first startup to ensure all services initialize properly. One organization I advised created a simple health check script to verify their stack was fully operational after startup. Let's explore the practical aspects of setting up monitoring in your ElkStack environment. This comes from years of experience implementing monitoring solutions in various organizations. Configuring your data source properly is crucial. When creating index patterns, consider using wildcards effectively. For instance, if you're using daily indices like logs, make sure your index pattern captures all relevant indices. For visualizations, start with the basics and build up complexity gradually. Some teams successfully implement monitoring by beginning with simple metric visualizations and progressively adding more sophisticated visualizations as they understood their needs better. Think carefully about the metrics you want to track. From experience, I recommend starting with key system metrics like CPU usage, memory utilization, and disk space, then adding application-specific metrics based on your needs. Dashboard creation is where your monitoring setup really comes together. When creating a new dashboard, consider your audience carefully. The arrangement of visualizations on your dashboard is crucial for usability. Place the most important metrics prominently and group related visualizations together. One organization I advise significantly improved their incident response time by organizing their dashboard to show correlated metrics side by side. Consider creating different dashboards for different time ranges. Some teams maintain separate dashboards for real-time monitoring, last 15 minutes, short-term analysis, last 24 hours, and long-term trends, last 30 days. This approach helps address different monitoring needs effectively. Remember to add appropriate filters to your dashboards. The ability to quickly filter by environment, service, or other relevant dimensions can make troubleshooting much more efficient. Real-time alerting is a critical component of any monitoring system. When configuring alerting in Kibana, start by clearly defining what constitutes an alert-worthy condition. Alert conditions need to be carefully crafted to avoid false positives while catching real issues. For example, one organization I advised implemented a multi-condition alert for their application errors. It would only trigger if both the error rate exceeded a threshold and the affected user count was above a certain level. Setting up actions requires careful consideration of your incident response process. Don't just set up email notifications. Think about how alerts will be handled. Some teams successfully integrate their alerts with incident management systems, automatically creating tickets for certain types of alerts. Remember to document your alert conditions and response procedures. This documentation proves invaluable during incidents and when onboarding new team members. We've covered a lot of ground in this module on logging, monitoring, and alerting with the ELK stack. Let me highlight some key areas where questions often arise in real-world implementations. One common question concerns scaling the ELK stack. It's important to understand that scaling isn't just about adding more resources, it's about optimizing your configuration and implementation. Consider questions about index lifecycle management, shard allocation, and cluster topology. Security implementation often raises questions. How do you secure your ELK stack without compromising functionality? I've helped teams implement role-based access control, encryption at rest and in transit, and network security measures while maintaining ease of use. Performance tuning is another area rich with questions. What's the optimal number of shards? How should you configure your Logstash pipelines? These questions don't have one-size-fits-all answers. They depend on your specific use case and requirements. I encourage you to explore these topics further and experiment with different configurations in your own environment. The hands-on experience you gain will be invaluable in your DevOps journey. Remember, the ELK stack is constantly evolving, so stay current with the latest features and best practices. Feel free to reach out with any questions as you implement these concepts in your own environments.